Okay, so let me find a random induction question. Since one of you asked. Let me see which induction question is good. All right, let's do this one. So let's say proof by induction that for all natural n that's greater than or equal to 2, we have the following inequality. Okay, so this is a induction question, and it involves inequality and also a sigma notation. So someone sent a picture. Okay, so that's that looks like strong induction. No, it's not. It's just an induction question. Okay, we'll do that one after we finish this one. So can someone tell me what is my base case?
N equals 2.
Okay, so proof. We proceed by induction on n, and my base case is when n equals to 2. So n equals to 2. Okay, so when n equals to 2, my left-hand side is k equals to 1 till 2 and 1 over k squared, which equals to 1 over 1 square plus 1 over 2 square. Okay, so this equals to 1 plus 1 over 4, which equals to 5 over 4. My right-hand side equals to 2 minus 1 over 2, which equals to 3 over 2. Okay, so since we're comparing those two, I'm gonna write it as 6 over 4. Okay, and since 5 over 4 is less than 6 over 4, base case holds. Okay, so that's base case. Any questions so far? So one thing you cannot do is you write something like this. Okay, do not do this. Do not do this because you'll lose mark. Okay, do not do this is you write something like this. And then you're like, oh, this is 1 plus 1 over 4, which is less than 3 over 2. And then we got 5 over 4 is less than 6 over 4. So we know this is true, so my base case holds. Do not do this, okay? Do them step by step and actually show this is less than, your left-hand side is less than your right-hand side. Anyway, back to the actual proof. My second step is inductive hypothesis. So I'm gonna assume this inequality holds. So k equals to 1 and 1 over k squared is less than 2 minus 1 over n. So one thing that I want to mention is because you have k here already, I know a lot of you likes to use, for some k in natural number, but since you use k here already, you cannot use k anymore. Okay, so you need to pick another variable, or another way is you can just write for some n in natural number, and when you do induction step, you can just prove for n plus 1. So that's what I'm gonna do. For some n in natural number. Okay, am I done with inductive hypothesis? Is there anything missing? Look at the question, is there anything missing? Okay, someone else post something? Yes, I'll go over that too. Okay, after the second induction question. All right, so something is missing from this inductive hypothesis because if you look at the question, they ask you to prove for all natural number which is greater than or equal to 2. So here your n has to be greater than or equal to 2 as well. Okay, so for some n in natural number, and n is greater than or equal to 2. Alright, so now our induction step. Alright, so induction step, we need to show this is true for n plus 1. So let's write the left hand side, k equals to 1, n plus 1, 1 over k squared. So I'm gonna start from this side. How do I use inductive hypothesis in induction step? I'll show you, okay? In a minute, I'll show you. So, note that we need to show this is less than 2 minus 1 over n plus 1. This is what we need to prove. Okay, so I'm starting from this side, but keep in mind that you want to use your inductive hypothesis. So somewhere in your induction step, you want to get something that's similar to your inductive hypothesis. So if I observe those two, I'll see that, well, I can write this as this plus the last term. So I'm going to do that. This equals to the sum from k equals to 1 to n, 1 over k squared, plus the last term, which is 1 over n plus 1 squared. So far, anyone has any question? Anyone question? What if n equals to 1? Well, n cannot be 1. Remember, our base case is 2 because this is only true for n greater than or equal to 2. Oh, you mean n minus 1? What do you mean n equals to n minus 1? Are you talking about, I'm not sure if I understand your question correctly, but are you talking about this? Okay, cool. So basically, if you want to write this as something that's this at something else, then you can write this. So it's last two terms. When k equals to n and when k equals to n plus 1. Plus 1 over k squared equals to this plus the second last term, which is 1 over n squared, and the last term, which is 1 n plus 1 squared. Oh, this is unrelated, so I'm going to use another color. Okay. All right. Now, now is your time to use your inductive hypothesis. Okay, and one of you asked. So for inductive hypothesis, once you get here, you see that, well, we have this in our inductive hypothesis. We know this part is less than 2 minus 1, 2 minus 1 over n. So we can use that. So if you use that, this is going to be less than 2 minus 1 over n plus 1 over n plus 1 squared. So this is by inductive hypothesis. Okay, let me put brackets here to show you which part is related to which part. Anyone has any questions so far? Okay, cool. So basically, we know this is less than this. So if we add this term on both sides, since this term is positive, okay, here I have a square. So if you add it on both sides, well, if you add anything on both sides, even if it's not positive, your sign's not going to change. Okay, so if you add this on both sides, you should have this is less than this. Does that make sense? And this step, we use the inductive hypothesis because we know this is less than this because we assumed that in the hypothesis. Okay, any other question? Okay, so keep in mind what we need to prove. So I'm going to write what we need to prove here. We need to prove, this means need to prove. So keep in mind we need to prove this. Minus 1 over n plus 1. Okay, so keep in mind this is what we need to prove. We are not close yet. Well, we have 2 minus, but this and this, they are not the same. Okay, so we want to do something such that this and this, they are the same thing. Well, now you can tell that they're definitely not equal. So, but here, remember we have a less sign, so you can keep making this smaller and smaller until you reach this. So what I'm going to do is I'm going to do this. I'll keep this term the same. And I'm going to write this term. Okay, I'm going to do something so that it's smaller. So what I'm going to do is I'm going to write it as 1 over n times 1 over n plus 1. This is because 1 over n plus 1 is less than 1 over n. Any question? Question? If not, this is equal to 2 plus, I'm going to factor out this to the outside. So 1 over n times minus 1 plus 1 over n plus 1. And this equals to 2 plus 1 over n times. So minus 1 can be written as minus n minus 1. Plus 1 over n plus 1. So that's 2 plus 1 over n and then n plus 1 minus n minus 1 plus 1, so that's minus n. Okay, now you see that we can cancel those two terms out, and we got this term already. So this is gonna give you 2 minus 1 over n plus 1 as required. Okay, so therefore, by principle of mathematical induction, this is always true. K equals to 1 over k squared is less than 2 minus 1 over n for all natural n greater than or equal to 2. Alright, any question? Step 4. 1, 2, 3, 4. You mean this step? This step. Oh, I factored out this. So let me write it here. So this is 2 minus 1 over n plus 1 over n times 1 over n plus 1. So I factored out those two terms, and I can get back to this. 2-step. Which 2-step? How did I get 1 over n 1 over n plus 1? Oh, I did this because I know I wanna how do I say this? I know I wanna do something so that eventually I can cancel out. I can get this. So you need some manipulation. It's not obvious. It's not obvious. So you need to try something, basically. Anyway, let me go back because a lot of people asked different questions already. So let me go back to the first question someone asked, which is another induction question, posted by Nitish. So let's do this one. Define a sequence recursively. So define a sequence recursively as follows. A0 equals to 3, an equals to plus an minus 1 for all n in natural number. Show that for all n in natural number union 0, we have an equals to n squared plus n plus 6 over 2. Okay, so let's do this one. For whatever you have, the questions will do them one after another, so don't worry. Alright, so for this question, what's my base case? Zero. Okay, so when n equals to 0, we have an equals to with 0, 0, which equals to 3. Okay, let's write the left hand side. Right hand side, we have a0 equals to 0 squared plus 0 plus 6 over 2, which is also 3. Therefore, base case holds. Let me write. Left hand side equals to right hand side. So base case holds. Now, inductive hypothesis. Assume that an, or yeah, let's choose an, equals to n squared plus n plus 6 over 2 for some n in what? What do we put here? For some n in what? Yeah, natural number with 0, exactly. Okay? Now, induction step. So we need to prove an plus 1 equals to n plus 1 squared plus n plus 1 plus 6 over 2. So I'm going to start with the left hand side. Was someone talking? No? Okay, cool. So we want to start with the left hand side, so an plus 1. What do we do here? What do I need to use here? Do I use a recursive definition? Do I use the inductive hypothesis? What do I need to use here? What's useful for me now?
The recursive definition.
Yes, so I need to use a recursive definition. This is a recursive definition, so I need to use this. Okay, so based on this, I know that every term equals to whatever goes here plus the term that's before this. So that means actually, hold on. Plus, would it be plus an or plus 1 plus an? I think it's plus an. So this is by definition. Now, an, we know an equals to this. Okay? So an equals to this. So n plus n squared plus n plus 6 over 2. This is by inductive hypothesis. Now you just need to manipulate this until you get this. But I'm gonna do some rough work because this is really complicated and it's hard to get from something simple to something more complicated. So let me do some rough work. This equals to n plus 1 squared plus n plus 7 over 2. Do I want to simplify it even more? Sure. So n squared plus 2n plus n plus 3n plus 1 plus 7 plus 8 over 2. Okay, so I know that I want to get something like this. So this is 2n. Oh, I see. It should be n plus 1 here. Yeah. Realize something. Here should be n plus 1. Sorry, guys. it means that this n, oops, where is it? Oh, here. This n depends on this n. So if you have n here, then you have n here. If you have n plus 1 here, then you have n plus 1 here. If you have n minus 1 here, then you have n minus 1 here. So it should be, just realize it, n plus 1. So 2n plus 2 over 2 plus n squared plus n plus 6 over 2 equals to 2n. So something over 2, which is n squared plus 3n plus 8, which equals 2. So now I want to go back to this. So I know this equals to n squared plus 2n plus 1 plus n plus 7. So I'm going to write 7 as 1 plus 6 over 2. And this part will give me n plus 1 squared plus n plus 1 plus 6 over 2. Okay, so this is what I need as required. So by PMI AN equals to n squared plus n plus 6 over 2 for all and in natural union 0. Okay, any question? Should we do GCD exam? We'll do the one before that question first, because someone else asked another question before the GCD question. We'll do that, okay? I believe we have time to do that. Okay. So let's do the third question. Someone asked another question before that. So let's do this one. Let me see. Let x plus y plus z equals to 5, where x, y, z are real numbers. Prove that x squared plus y squared plus z squared is greater than or equal to 5 over 3. Let me think about it. I think I did this question before, but it was really complicated, and I believe there must be an easier way to do it. I think when I did it was I used basic fact, which is like something square is greater than or equal to 0, but there must be an easier way to do this, and let me try this. You guys can think about it too. Oh, I think we can do it in this way. Yeah, this is from last winter. Yeah, when the first, I think it's the very first online exam we ever had before. So yeah. Oh, I think we can do this. So suppose, so proof Um, so since it's 5 over 3, okay, so suppose without loss of generality, so assume that x is less than or equal to y, which is less than or equal to z. So could be the other way around, but it doesn't matter in this case because they are symmetric. If you switch x, y, z a position, it's still the same. That's why I use the without loss of generality. But anyway, so in this case, my z would be the biggest number. My x will be the smallest number. Then, since x plus y plus z equals to 5, this is gonna imply that my z is greater than or equal to 5 over 3. For this one, anyone has any question? I cannot assume they are equal. No, this is here. I cannot assume they are equal because they might not be equal. So I assume that they are one is greater than or equal to the other. Yes, it's because if I interchange z with x or y, the answer will be the same. Because why not is for what? For assume they are all equal? Why not? Because they might not be all equal. You don't know if they are equal or not. So if you prove that they are all equal, no, I mean if you prove that this is true when they are all equal, but what if they are not equal, then what are you gonna do? Do you understand what I mean? Farah? Yes, okay. So that's why you cannot assume they are all equal. But this all always work because x and y and z, even if you interchange them, it's still the same. For the question itself, it's still the same, and this covers all the cases because they are either all equal or one of them is two of them are equal or they are all not equal, which means one has to be greater than the other. So this is always true, but you cannot assume they are all equal. For this one, you need to think about this. Try to convince yourself. If you cannot, try to assume that it's not greater than or equal to 5 over 3, then what's gonna happen? But so let's say if I got this, do you guys know what's gonna be the next step? Okay, I'll say how did I get 5 over 3? Because when they are all equal, then each of them is 5 over 3. We know that those two numbers are less than this number. So, how do I say this? Okay, let's say this. It's not a formal proof, but let's say this. This might make you understand it better. Let's say x and y are 0. Then your z is gonna be 5, which is greater than this. Let's say x, let's make it be as big as possible. Okay, let's make it be as big as possible. Let's say x equals to 5 over 3. Y equals to 5 over 3 as well. Then your z has to be 5 over 3. If x or y, any one of those, are bigger than 5 over 3, then your z is definitely not bigger than x or y. But the proof itself, you should think about this y. Well, I think someone already showed you a proof already. So this shows that 5 over 3 is less than... Wait, did I write it wrong? No, I didn't. No, this shows that 5... Oh, yeah. We know x, y, z is less than or equal to x squared, y squared, z squared. So, wait, but you're talking about the multiplication? Or you just forgot to add a plus in between? No, z square. Nitish, z square. So z square is greater than or equal to 25 over 3. So this is greater than 5 over 3. We know this is already greater than 5 over 3. So if you add two non-negative number, it's going to be definitely greater than 5 over 3. So, what did I write? Oh yeah. So since, also x squared is greater than or equal to 0, y squared is greater than or equal to 0. So we'll get x squared plus y squared plus z squared is greater than or equal to 5 over 3. Oh yeah, it's 25 over 9, sorry. It's 25 over 9. That's a typo. But that's still greater than 5 over 3. Can't you prove it the way I did? Okay, let me see the way you did. You just missed plus in between, right? Yeah, okay, let's see. We know that x plus y plus z is less than or equal to x squared plus y squared plus z squared. Why is that? This, I'm not sure if that's true. I don't think it's true, to be honest. For example, yes, it's in real, that's why. For example, if there are something like 1 over 2, then you know that 1 over 2 is greater than 1 over 2 squared. For negative numbers as well, yes. So your first step is not true. Okay, so after this question, let me go back. I think after this one is a GCD one. Yeah, GCD. Okay. The GCD one is find integers xy such that 21x plus 13y equals to 1. This is a question, right? Okay. We do this one first, and then we have another equivalence relation question after. Yeah, So from this, what you need to do is those two numbers, okay? You use Euclidean algorithm to find their GCD. So 21 equals to 13 times what? Plus what? Anyone? Times 1 plus what? Plus 9, okay? And then 13 equals to 9 times 1 plus 4. 9 equals to 4 times 2 plus 1. And then 4 equals to 1 times 4 plus 0. So you do this first. It's plus 8. Oh yeah, it's
Yeah,
plus
it's 13
8.
plus 8.
Yeah, I didn't check. It's okay. Fix this easily. So it's 3. Sorry. 8 plus 5. Okay, now it's good. Anyone mind check my math? Should be good. Looks good. Okay, so this is my first step. My second step is, well, wait. This doesn't look right. Something's wrong here. I missed the 5. Wait, which 5? Oh, right. Yeah, you're right. Thank you. That's why it doesn't look good. Yeah, this looks right now. Okay, now this looks good. Okay, any other problem? Now the GCD is 1. Yeah. Okay, this makes sense. I think this is good. Yeah. Okay, so the trick for those type of question is you need to do this first. You need to write down the Euclidean algorithm first. And then you do backwards of what we're doing here. So you want to write 1 equals to something. So I'm going to start with this step. And I'm going to call this 1. So I'm going to start with step 1. And I'm going to rearrange it. This means that 1 equals to 3 minus 2. Okay, so this is by 1. And then I know that 2 can be written as 5 minus 3. So let's call this 2, which equals to 3 minus 5 minus 3. Okay. Now I'm gonna open a bracket and I'm gonna combine those two together. So this equals to 3 minus 5 plus 3. And I'm gonna group those two together. So that's 3 times 2 minus 5. Okay? Any questions so far? Now, we're not there yet. We need 21 and 13. So we have 5 here, and we have 3 here. So we can write 3 as 8 minus 5. So this is step 3. Minus 5. Okay. Now, open the bracket again. So this is 8 times 2 minus 2 times 5 minus 5, so minus 5 times 3. Okay, so now, again, remember we're going back. So now we need to write 5 as 13 minus 8. So this is 4. So 8 times 2 minus 13 minus 8 times 3. This is 4. And this, you open a bracket again. So 8 times 2 plus 8 times 3 is 8 times 5 minus 13 times 3. And lastly, well, we have 13 already. Lastly, we have 8. So this is 5. Let's write 8 as 21 minus 13. This is 5. Okay, and then open the bracket. So eventually you'll get 21 times 5 minus 13 times 5 minus 13 times 3. So minus 13 times 8. And that's your final answer. So eventually you'll get, what do you get? So you'll get x equals to 5 and y equals to minus 8. Any question? Okay, let's look. Can you post the tutorial on YouTube right after class? This is not tutorial, this is office hour. Yes, I got requested by a student in Accessibility Center because he or she, they were like, because they said the test, the computer science exam, their writing ends at 8:30 for them. So so I said yes, I will post it. So yes, I will post it. Probably not right after, because it takes time for them to processing the video. So I'll post it right after I got the video. Okay. Okay. What's the next question? Let's see. GCD. After GCD is this. Okay. So the next question that's being asked is this one. Define a relation on the set of all real number x, y in real number, and x has a relation with y if and only if x minus y is an integer. And then they want you to prove this is an equivalence relation and find the equivalence class of 1 over 3. Okay, since we have 5 more minutes, I'm not going to do any other questions, so this will be our last question. After this, I want to talk about something I think that's important. So, and then that's the end of the office hour. Anyway, so we need to prove it's an equivalence relation. So what do we need to prove? Which 3 properties do I need to show? Reflexivity, symmetric, and transitive. Okay, exactly. So let's show reflexive first. For reflexive, what do you need to show? Okay, x has a relation with x. So we need to show that. So we need to show for all x in this case is real number. So for all x in real number, x has relation with itself. Okay, so let's pick let x be in real number. So to show that it has relation with itself, we need to show x minus x is an integer. So x minus x equals to 0, which is an integer. Therefore, x has relation with x. And they didn't say the relation is something. Okay. Therefore, x has a relation with itself, and the relation is reflexive. So that's reflexive, symmetric. So we need to show, let me write it here, which is x minus x is an integer. We need to show for all xy in real number, if x has a relation with y, then y has a relation with x. In other words, we need to show that x minus y is an integer implies that y minus x is an integer. Okay, so let's pick 2 variables in real number. So we pick any 2 arbitrary elements of real number, and assume that x minus y equals to k, where k is an integer. Now we need to show that y minus x is an integer as well. So y minus x, which equals to negative of x minus y. So which equals to negative k, which is an integer. Since k is an integer, therefore y has a relation with x, and the relation is symmetric. That's the second question. No, the second part. The third part is transitive. So transitivity, we need to show, for all x, y, z in real number, if x has a relation with y, and y has relation with z, then x has relation with z. In other words, you need to show that x minus y is an integer and y minus z is an integer, implies that x minus z is also an integer. Okay, so this is what we need to show. Now let's pick x, y, z a real number, and suppose x minus y equals to k, y minus z equals to l, where my k and l are integers. Now I need to show x minus z is also an integer. So x minus z equals to x minus y plus y minus z, which equals to which equals to k plus l. This is definitely an integer, since k and l are integer. Okay, so this shows that x has a relation with z, and the relation is transitive. The relation is transitive. Okay, so now we show that it's reflexive, symmetric, and transitive. We can say it's an equivalence class. So since the relation is reflexive, symmetric, and transitive, it is an equivalence class. Equivalence relation, sorry. Okay. Scroll up. Is this good? A little bit more. Like this. Okay. So now we need to find the equivalence class of 1 over 3. Now, what's the definition of equivalence class? Anyone remember? So equivalence class of 1 over 3 equals to what? What is the set itself? Okay, nobody said anything? All x such that 1 over 3 minus x is in z? Yes. Okay, so this means that all x in real number such that 1 over 3 x, let me write like this, such that 1 over 3 has a relation with x. In this case, it's exactly what you said, such that 1 over 3 minus x is a integer. So what can we write? How do we express? doesn't matter if it's 1 over 3 minus x or y minus 1 over 3. Since it's equivalence class, it doesn't really matter since it's metric. For Raj Patel, your question, it's since it's an equivalence class, we know it's symmetric, so it doesn't really matter. Lucas, 1 over 3 minus x equals to m for some well, what you wrote and what's here is there is no difference. Okay, Amelia said any n over 3 such that n equals to 3m plus 1. I think you can just write something like let me think. I think you can just write something like an integer plus 1 over 3. Yes, every integer plus 1 over 3. Or you can write what Lens wrote. So you can write actually I don't want to write it like that. Let's just say x equals to which variables do we use? X, Y, Z. So let's use something else. Equals to k plus 1 over 3, where k is an integer. Or you can, there are many ways to write it, or you can write whatever Lens wrote. Like negative 5 over 3, negative 2 over 3, 1 over 3. Yeah, both are okay, I think. Okay, so I think I'm not gonna do more questions, but I wanna talk about something that I think it's important. So hear me out. To prepare for an exam, you have part A, which is multiple choice or fill in the blank questions. So I'm gonna talk about this. I think they will test you inequality in part A because that's, if they have multiple choice, it's the best way to test you on inequality. So make sure you know AGM. For AGM, make sure you know how to find the maximum and minimum. Okay? This is really important. So whenever they ask you what's the maximum value of an expression, you should think about inequality. Okay? So for maximum, is that greater than or equal to or less than or equal to? So for example, I'll find maximum of, let me just make something up. Find max of what do I want to write? Of A. So do I want A greater than or equal to something or A smaller than or equal to something? A is less than or equal to something. Okay? For minimum, you are trying to find A is greater than or equal to something. So I think that might be in your part A. So part A, which is number 2, triangle inequality. If it's multiple choice question, what's the best way to do multiple choice question if they are given triangle inequality? You plug numbers in. Don't waste your time to prove them. Plug in numbers. Okay, don't tell your professor I said this, okay? That's not what they want you to do, but the fastest way to do this is plug numbers in. Let me find the past exam and show you what I meant. Let me find something. Past exam. Oh, here. So let me find the past exam and show you what I meant. Even if it's not multiple choice, it's like, oh, they ask you which one is greater or which one is smaller. You plug numbers in to see which one is bigger, which one is smaller. Wow, I can't find anything now. Yeah, I can't find anything now, but I'm just gonna give you a stupid example. For example, which of the following is true or which of the following is false? And they have something like, not just triangle inequality, okay? For AGM as well. For example, one is something like, oh, 1 over this times 1 over y is less than or equal to 1 over xy. 2 something something something. Doesn't matter what the options are. Since if it's true, it has to be true for all real numbers or for all positive real numbers. Whatever the restriction is, you plug such numbers in, then you'll get this, okay? Don't try to prove them. That's gonna waste a lot of time. If it's multiple choice, plug numbers in. Don't waste your time on anything. Let me think what else could be put on. Let me grab my 102 book. Oh, this power set is a good one. Power set. So they can ask you something like, let A, so example, let A be a set. They might put something weird in, and then they ask you what's a power set of this. So put something weird in. Though in that case, I don't know what they'll put in, but they can put something weird. Make sure you know how to compute power set. That's pretty important. Let me think what else could possibly be there. Again, don't tell professor I said this. It's not good. Oh, another one. GCD is another one, because it's easy to ask you GCD questions. So make sure you know the weird one. By weird, let me find a weird one. Something like, I need to find a weird GCD question. I don't know, something, it's hard to say. Oh, this one. For example, it's in the past exam, but I think it's a good one. For example, GCD of 3n plus 2, 2n plus 1. Or something like, oh, GCD of something to the power of a really high power. That could be one of the part A question as well. Let me show you some examples. I can't find anything. Something like, let me just make something up. 7 to the power of n plus 4, and then 7 to the power of n. something like that. Okay, so some weird thing could be be like here. Okay, so that's another one that could be tested. Another good question that could be tested as part A would be, oh, negation. It's almost guarantee will be there. Negation, so negate something, or which of the following is true. So not really negation, mathematical statement. So which of the following negation is the correct one, or which of the following statement about failed, or which of the following statement about something is correct. I don't know what your test, I don't know what your exam look like. I'm just guessing right now. Okay, I have no idea. Yeah, I'll do that. Who's that? That's my boyfriend. Okay, which of the following is true? Is true or false about, let's say, about inductive hypothesis, so IH, or like about fields, and so many more could be there. What else? Let me think about it. Yeah, but tests are easy to predict. Exams are pretty hard to predict. Come on, guys. Exams, I usually don't do prediction because exams are really hard to predict. Statement, I think there is something else you can ask. So statement, this is the first type. The second type, let me think about it. Oh, another one is equivalence relations. Definitely gonna be tested. So they can ask you, oh, is this an equivalence relation? So if they ask you something like this, do transitivity first, because usually this is the one that failed. Anyway, another way is they can ask you, oh, which of the following is in the equivalence class of something? So that could be there as well. So make sure you know what's equivalence class. Which of the following is in equivalent class of something? So that could be there as well. I'll just talk whenever I come up with something, but can't guarantee anything. What else? Let me have a look at past exams and I'll think about more. Past exams. Oh, image. What's the image of something? Basically, what's the image of something? Or which of the following is the image of a function? Oh, for this mathematical statement, let's go back because I just thought about a question they could ask. Let me get the textbook. What's the hack to image questions? Hard to say. Okay. Yes, decimals. I didn't say that. I didn't say decimals, so I didn't say that. If they give you something that's not from R to R, then decimals doesn't help, isn't it? Well, I don't think any professor would watch my video, so it's okay. Just don't tell them I said anything. Yeah, be serious. What's the hack of image? If they didn't ask you to prove something, the one hack is you can put some numbers in and try if you can find a pattern through that. So especially if it's like integer to something or natural number to something, you plug in some numbers in. Okay, plug numbers in and see. Is decimal academic offense? I think so. I don't think you're allowed to use decimals. Yeah, it's academic offense. So don't use that. Yeah, but back to statement, I just thought about a good question. Oh, actually not back to statement. Another thing they can ask is this. Sigma and pi notation. Because they can either put that, I think they'll put that in multiple choice because it's easier to test you on this. For multiple choice questions, it's easier to put it on this. So make sure you know how to compute those. What is? Oh yeah. For this one, I think something they could ask that's really good is this one. Back to mathematical statement. 3.7.10. This is a good question. Okay, try that one. For multiple choice questions, that's part A. Part B, this is harder to predict, but you know induction will definitely be there. This is guarantee will be there. How many, wait, hold on. Okay, long answer. How many questions are there for part B? Anyone know? 5, okay. So one is induction. Let me look at, can someone send me a copy of the exam jam question? Because, well, Stanley knows what's going to be on the exam, so I suppose he's going to do something similar to the exam on the exam jam. So, yeah, cardinality, yeah, you're right. I missed that one. Cardinality. Yes, that one is almost definitely gonna be there. GCD, I doubt that. Because for GCD, I think they'll test you in part A. But you still need to know it though. Yeah, I don't think cardinality is gonna be multiple choice. But cardinality induction almost guaranteed in part B. Wait, anyone has a exam jam question? Okay, let me just check. I don't think your exam's gonna be super straightforward. So I think they will put questions that requires you to think. Modular arithmetic. For this one, Let me think. Oh, and injective, bijective, surjective. Modular arithmetic, make sure you go over in class, like breakout room questions. Pretty important. Those are pretty important. What else? Divisibility. I think that might be there too. Divisibility. How do they test you on this? Basically, chapter 6, I think is a contradiction question, which involves like irrational number. So show that this number is irrational or rational. Could be there too. Failed. Okay, so I'm struggling. I would say this could be here too. So which of the following is rational? Or irrational? Or could be here. Also could be a failed question. So I highly doubt that, okay? So I highly doubt that. This one, I think it's failed or image question, to be honest. But image question is really similar to surjectivity. So 10 multiple choice question. I think I should get at least 80% correct for part A. Part B, it's hard to say, but part A, because there are only certain things you can put it on multiple choice. Oh, I think field question, image question, I doubt that because image and bijective functions are really similar. So let's put /image. 6 is very unlikely to be there, I would say. I think it's harder than your test and your quizzes. But it should be still fair, okay? Not trying to scare you, still should be fair. Yeah, this is my thought about your exam. Anything? Equivalence class? Could be there, but very unlikely, I think. Pretty unlikely. Let me think. Okay, yeah, I think, okay, or equivalence class, but I don't think it's gonna be here. Equivalence relation. Because usually this is like too easy and I don't think they'll give you a straightforward question like this. So 1, 2, 3, 4, 5 most likely. 6 is very unlikely. I don't know. Should be something like this. How they will have 12 marks for each question. It's pretty real, to be honest. If you look at the past exams, they all worth a lot. Wait, did I put set equality there? Oh, I forgot set questions. Yeah. Sorry. Sex should be set identity question. How could I forget about that? Set. And this is 7. Okay. The first 4 are very likely to be there, so practice a lot. For this one, know the graphs of functions are really important. So for example, ln x e to the power of x arc10 1 over x plus 1. What else? Arc cosecant. And many more. Okay, so know the graph. Sometimes that could help you a lot. Induction should be easy. Injective, surjective image. For this one, make sure you know when they have Cartesian product and when they have Cartesian product and when they have what else? When they have absolute value. Okay. Oh, contradiction could have something that involves or contrapositive. So make sure you know how to write even odd question. Those are tested a lot. You don't know how to do that. Oh, absolute value. Check one of the tutorial videos. Okay. Cartesian product. Check one of the office hour questions. I don't know which one office hours, or it was some quiz review office hour video. I did Cartesian product questions. Our videos. And this one, I think it might take you a lot of time. So make sure you do a lot of questions on this. Okay, I think that's it. Which tutorial? Okay, let me see your questions. About your post, I have no idea. I'm not a CS person. I just want to know how to show symmetry with absolute questions. For absolute questions, okay, let me just mention it and I'm gonna leave. So for this, remember you can write this as this. Okay, always remember this. But I think with these absolute questions in tutorials, so check that. And I think that's it. Oh, for this one, I think Bezos' identity are pretty. Bezos' identity are pretty useful a lot of time. Another time is try the first few, and you might find a pattern if they for certain questions. I don't know. I think that's everything I can say. First few means when n equals to 1, n equals to 2, n equals to 3, n equals to 4, and you might find some pattern. Does that make sense? Okay, I have to go. So that's it. Everyone, good luck on your exam. You can email me. You can email me if you have any question, or you can DM me on Discord or Instagram or whatever you have me. I think that's it. Good luck. I hope all of you can do well. Don't panic. Okay, make sure you don't panic, because if you're panicking, your brain goes blank and you will do much worse than you should do. So don't panic during the exam. If you don't know how to do a question, move on, come back to that question. Okay, make sure you try every single question. Don't leave anything blank, because your professors are really nice. They might give you partial mark. Okay, so don't leave anything blank. Try every single question. Write down what you have. No, I mean write down what you have in mind. So write down everything you know. Even if you don't know anything, write down something you know. Okay? All right.